Fuel pumps and injection nozzles are engine parts which, like others, are very important to engine efficiency as well as engine life. So let's take a look at the entire fuel system, focusing on fuel injection pumps and injection nozzles to see why Caterpillar details do make a difference. Pump and lines type fuel systems are comprised of a fuel tank, primary fuel filter, fuel transfer pump, secondary fuel filter, hand priming pump, fuel injection pumps, and injection nozzles. From the fuel tank, the fuel usually flows through a primary fuel filter, which acts like a strainer. It removes large particle contaminants to protect the fuel transfer pump from damage. The next component in the fuel system is a fuel transfer pump, which supplies fuel at a controlled pressure to the secondary filters and fuel injection pump housing, approximately 30 psi. Two types are used, either a gear type or a piston type. The job of the secondary filter is to remove any remaining particles in the fuel, which may be harmful to the fuel system. This filter should be changed at recommended change intervals, or when a loss of power is noticed. Some fuel systems have a hand priming pump and bleed valve provided to rid the fuel system of air that may enter when filter elements are being changed or lines disconnected. If air is in the fuel system, engine starting becomes difficult and can even cause the engine to miss while running. Next, the low-pressure fuel flows to the fuel injection pump housings. These housings are normally located on the side of inline engines and inside the V on V engines. With the exception of the 3500 1.7 and 1.1 liter series engines, Caterpillar uses two types of injection pumps, the scroll or helix type and the sleeve metering type. The difference between the two pumps is apparent in their internal design. The job of the individual injection pump is to meter and deliver fuel to the injection nozzle. With both systems, the vertical motion of the plunger injects the fuel. With the scroll type system, a rotary motion regulates the quantity of fuel injected. In a sleeve metering system, the quantity is regulated by the vertical position of the sleeve. One major difference between the two systems is that of lubrication. Scroll-type pumps use engine oil for lubricating the camshaft and lifter-follower mechanism. Sleeve metering pumps use diesel fuel for lubrication of internal pump components. Fuel-lubricated pumps can be damaged by water contamination. Care must be taken to ensure water is removed from the fuel because it breaks down the lubrication function of the diesel fuel and can cause corrosion. To eliminate the problems encountered with water in the fuel, a water separator group is used. It is important to regularly drain water from the separator to ensure efficient operation. Fuel leaves the injection housing through high-pressure, seamless steel delivery lines and travels to the injection nozzles. There are two types of nozzles used on Caterpillar engines. Capsule-type nozzles, which are used on all pre-combustion engines and some direct injection engines. The long, small diameter nozzles are used only on direct injection engines. The reason we have both capsule and pencil nozzles on direct injection engines is basically one of design evolution. Today, the trend is to pencil-type nozzles on direct injection engines. There is one nozzle for each cylinder. The nozzles spray fuel delivered from the injection pumps to the cylinders for combustion. With the pre-combustion chamber engines, fuel is injected into a pre-combustion chamber where the fuel-air combustion is started. As the fuel begins to burn, expanding gases force the fuel into the main combustion chamber where complete combustion occurs. With direct injection engines, fuel is injected directly into the cylinder where combustion starts and is completed. Caterpillar is moving towards direct injection because it gets better fuel economy and involves less heat rejection than pre-combustion engines. So, the main job of a fuel injection nozzle is to spray atomized fuel into the combustion or pre-combustion chamber. Here you see a PC capsule-type nozzle. High-pressure fuel enters the nozzle at the top, passes through a screen, and then injects when pressure is high enough to unseat the check valve. On pre-combustion engines, fuel is sprayed through a single hole at the bottom of the nozzle. The direct injection capsule nozzle has multiple holes because finer atomization is required for complete combustion, and because it has to spray over a larger area than the pre-combustion nozzle. The long, slender direct injection nozzles and capsule nozzles operate similarly. High-pressure fuel from the injection pump enters the nozzle, then fills it and surrounds the valve. When the pressure is high enough, the valve will move upward, allowing the fuel to spray through multiple holes. With the introduction of the 3500 1.1 and 1.7 liter series engines, Caterpillar is using a different method of fuel injection. The direct injection combustion system uses a unit injector. The unit injector combines a scroll-type pump and a nozzle into one unit. The combined pump and nozzle design eliminates the need for very long high-pressure delivery lines. There are two types of unit injectors: mechanical, as used in the 3500 and 3116 engine, and electronic, as used in the 3176 engine only. As you all know, nozzles are a highly competitive part. When we talk about nozzles, names such as IPD, Corrodi Collier, Diesel Master, and Unidiesel usually come to mind. When we take a look at these competitive nozzles, we find that they appear very similar to Caterpillar nozzles. But even though they look alike on the outside, they are not comparable. Caterpillar is continually making design improvements to our nozzles without changing the part number. Our competitors don't know this and often use the same design we abandoned years ago. Here is an example of such a design change. The old-style nozzle had a separate seat that fits into a counterbore in the tip. The counterbore is machined to very close tolerances to accommodate a gasket to complete the seal. This increases the number of mating surfaces and creates potential fit-up and leak problems. Today's nozzle has a finely lapped or polished tip and one-piece seat for greater precision and fewer fit-up problems. This improved design eliminated the critical counterbore machining and eliminated the gasket as a variable influencing fuel delivery. Remember, if a competitive nozzle fails and causes engine damage, all a supplier may lose is the nozzle business. If a Caterpillar nozzle fails, we have much more to lose, namely customer engine business. Another difference from competitive nozzles is the special high-strength, heat-resistant wire specified by Caterpillar engineers. Spring tension directly affects timing and the amount of fuel injected into each cylinder. Deterioration of spring tension can result in reduced fuel mileage, increased smoke, reduced engine life, horsepower growth, and, in extreme cases, engine damage. The spring specified by CAT helps prevent these problems so that the nozzles will provide consistent fuel delivery. Inadequate machining can also cause problems in nozzles. Let's look at some of these problems, starting with the screen. We have observed screens in some competitor nozzles that had an incorrect weave, which would not provide adequate filtering. Also, some competitors' screen wires are not being fused together. High-pressure pulses can break off the loose end pieces, which can lodge between the check valve and the seat, causing the nozzle to leak. This can result in lower fuel mileage, increased exhaust smoke, undesirable horsepower growth, crankcase dilution, and/or piston seizure. We have also seen machining problems with the sleeve in competitors' nozzles. Burrs left on the sleeve could break away and lodge between the check and the seat, causing a leaky nozzle. Sometimes the internal surface of the sleeve is so rough that it wears the outer diameter of the spring, resulting in a lower tension spring, subsequent fuel rate growth, and eventually a broken spring. Another problem which has been found on competitive nozzles CAT has tested is often the machined surfaces of the check and the seat are rough. This insufficient machining of these surfaces will in time accelerate wear, causing check pitting, resulting in a leaky nozzle. Caterpillar machines these surfaces using specially designed grinding equipment to provide accurate, smooth, leak-free surfaces that also resist change in fuel delivery after they are put in service. Horsepower growth is a direct result of fuel rate growth, and because the engine user seldom thinks of high horsepower as a problem, it may go undetected. But high horsepower places unusually large stresses on engine components, and the life of these components will be greatly reduced. Other competitive nozzles tested had oversized orifice diameters. This results in a high fuel rate. Again, this causes horsepower growth and excessive stresses on the engine. In summary, we've outlined many reasons why Caterpillar suggests only genuine replacement parts be used with CAT engines. For long-term performance, latest design, and good fuel mileage, advise your customers to use CAT nozzles, which are specifically designed for CAT engines. It's worth paying a little more where the risk of engine life and performance is at stake. Remember that details really do make a difference.